So what we're going to be looking at today is section 4.4, which are the trigonometric functions of any angle. The first thing that we want to do is we want to know what the definition of the trigonometric functions of any angle are. So what we're going to be looking at is our angle in standard position. Okay, so here's our angle. And what we're going to define, so the angle is theta, and what we're going to define next is r. And r is the length of the terminal side of the angle theta. So this is r here. So in other words, what we can do is we can draw a triangle with the x-axis and the terminal side of the angle. Okay. And in order to figure out what r is, we know that it's a triangle. This side's going to be x, and this side's going to be y. So we're going to remember our Pythagorean theorem. So we have x squared plus y squared is going to be equal to r squared. So this side right here. In order to find what r is by itself, we're going to take the square root. So we're going to take the square root of this side and this side. So r is going to be equal to the square root of x squared plus y squared. And remember that r is the length of the hypotenuse, so it's always going to be positive. So what we want to look at now is what happens if we have the point 2, -4, and it's on the terminal side of the angle in standard position. What we want to do is we want to find the exact value of sine. Okay, so let's start. We want to see where the point 2, -4 is. So let's go ahead and draw our axis. So 2 is on this side, so the positive x, and then 4 is going to be negative, so it's where our negative y is. So there's like 1, 2, and then 1, 2, 3, 4. So I'm going to plot my point right here. This is going to be the point 2, -4. I'm going to go ahead and draw a line because I want to make that triangle just like we saw in that first slide. Okay, so we know that this point right here is 2, -4. And make our triangle. That's the right triangle. Okay, we know it goes like this. And what we need to do now is we know that the x coordinate here, the x side of our triangle is 2, and then our triangle is 4 tall. What we need to do is we need to find what the hypotenuse of our triangle is. So we have 2 squared plus 4 squared is going to be equal to r squared. So 4 plus 16 is equal to r squared. 20 is equal to r squared. So the square root of 20 is going to be equal to r because we took the square root of both sides. We do want to break this down, so the square root of 20 is equal to the square root of 4 times the square root of 5, so it's 2 square root of 5. So that's going to be our r. So I'm going to label this on our triangle, 2 square root of 5. So now we know all the pieces. We know our x, we know our y, and we know what our r value, which is 2 square root of 5. So in order to find the sine of theta, we know it's going to be y over r, just like it's listed down here. So what we need to do is we need to look at the pieces that we have. Our y coordinate is going to be -4. So the sine of theta is equal to -4. And then our r value is just what we found here, 2 square root of 5. So now the last thing that we need to do is we need to maybe reduce this, and then we're going to need to rationalize it. So let's reduce it first. So it's -2 over square root of 5. And when we rationalize, remember we're going to multiply by the square root of 5 at the top and bottom. So we have -2 square root of 5 over 5. So the exact value of sine of theta is going to be -2 square root of 5 over 5. So sine of theta. Let's look at another example. So let's say now we have the point -2410 is on the terminal side of an angle in standard position. And once again, we want to determine the exact value. This time we're looking for the exact value of our secant function. So we're going to start the same way. We're going to draw our axis. And we want to know where -2410 is. -24 is negative x, so right here, and then +10 is on the y. And so let's kind of estimate, let's say right here is the point -2410. And once again, we want to draw our radius going from the center of our axis. We want to draw a triangle. Let's draw a triangle. It's going to be a right triangle. Remember, it's formed with the x-axis on the terminal side. And once again, we want to label kind of the lengths of our triangle. The x length right here is going to be coming from the 24. And the y, how tall the triangle is, comes from the 10, because that's our y value. And just keep in mind that this 24 is negative because it's in the second quadrant. We still need to find what our radius is, or our hypotenuse. So we're going to use the Pythagorean theorem to do that. So we have 10 squared plus 24 squared is going to be equal to that r squared that we're trying to find. 10 squared is 100, and 24 squared is 576. It's going to be equal to r squared. Add them together, we have 676 is equal to r squared. So in order to find what r is, we're going to take the square root of both sides. So r is going to be equal to 26. You could have done this right away if you remember the relationship of the 10, 24, 26 special triangle that you learned in geometry. If not, we could go ahead and find the hypotenuse this way. So that side's 26. So now what we want to do is we want to find the exact value of the secant. Okay, so we have the secant of theta is equal to r over x. Okay. R we found was 26, sorry. So 26 is equal to r. And our x value, remember it's negative, it's going to be -24. So the secant of theta is equal to 26 over -24. We can go ahead and reduce that also. So the secant of theta is going to be equal to -13 over 12. Let's look at the last example. Oh, not the last example for today, but second to last. What we want to do is we want to state which quadrant theta lies if secant of theta is greater than 0 and the cotangent of theta is less than 0. So here, we have to remember where our signs are positive and negative. So remember, x and y is positive and positive here. X is negative here. Y is positive here in the second quadrant. In the third quadrant, our x's are negative and our y's are negative. And then in the fourth quadrant, our x's are positive and our y's are negative. Okay, so now we know where our x's and y's are positive and negative. So this is going to help us determine where secant. So remember, our secant of theta is equal to r over x, and then where our cotangent of theta is equal to x over y. So remember, we said that r is going to be always positive. So we're looking for a quadrant where the secant is going to be positive. So it could be positive in this first quadrant because r is positive, and then we're looking where the x's are positive also. So far we have 2 places in the first quadrant and in the fourth quadrant because the x is positive there. And then what we want to do is we want to see where the cotangent is negative. Remember, our cotangent is x over y. So we can have kind of two possible things happen with the cotangent. The x's could be negative, or the y's can be negative. So let's see, where the x's are negative is here, and then here. Okay. So those are where x's are negative. Or we could also have it where our y's are negative also. So then we'd have this one down here and this one down here. And what we're looking for is we want to see which quadrant both the secant and the cotangent. So the secant's positive and cotangent's negative. So it's going to be this one down here. It's the fourth quadrant. An easier way to remember this is using this kind of rhyme. It's all students take calculus. So here all our trig functions are positive. Here the sine and cosecant are positive. Here the tangent and cotangent are positive. And here the cosine and secant are always going to be positive. So this would be a little bit quicker way than going through each coordinate. Let's look at the last example where we want to find the exact value of sine theta and the cosecant of theta if cotangent of theta is undefined, and we know that we have a theta lies between pi over 2 and 3 pi over 2. So the first thing that we want to do is we want to see where we're working. So remember that we have pi over 2 here and 3 pi over 2. So we're going to be working in this quadrant and this quadrant, and maybe even on one of the quadrant angles. And we have to go back and think. We want to know, well, where's the cotangent undefined? If we look back at the unit circle, we know that the cotangent of theta is undefined at pi. So that's what we're going to use. We know it's undefined at pi, and pi does lie between pi over 2 and 3 pi over 2, so we're good. So now what we want to do is we want to find the sine of pi and the cosecant of pi also. So remember the sine of pi, sine is y over r. So we're going to be looking at the coordinates of pi, which are 1, 0. Negative 1, 0 since we're going this way. So we have 1 here and 0. So what we're going to find is the sine of pi is going to be 0. Remember, our cosecant is going to be r over y. And in this case, what we find, r is 1 and y is 0. So what we're going to get that our cosecant of pi is also undefined.